So let's have this sample exercise. The weights of 1,000 children average 50 kilograms and the standard deviation is 5 kilograms. How many children how many children weigh between 40 kilograms and 55 kilograms? So let's write first the given values here. So we have the total number of children, which is let's denote it as a capital letter N. So 1,000 children. And we have here, since this is, I think that we're taking a sample of 1,000, so the average weight here is going to be denoted as our sample mean, which is x bar, is equal to 50, while our sample standard deviation, which is denoted by a small letter s, is 5 kilograms. Okay. First step. The first step here is to determine the z-scores. We have to determine the z-scores that correspond to 40 kilograms and 55 kilograms. Okay, it's bigger. So we have this formula, z-score formula for sample data. Okay, and this z is equal to x minus x bar, or our sample mean, all over our sample standard deviation. So let's divide the space that we have here to identify the z-score that correspond to 40 and 55. Let me just align. Okay, so let's denote for the first z-score as z sub 1. So z sub 1, right? Okay, z sub 1 is equal to our raw score, which is 40 first, so x sub 1, which is 40 minus our sample mean, which is 50, all over our sample standard deviation, which is 5. Okay, and we have here our z sub 2, which is equal to our 55, sorry, it's 55 minus 50 all over 5. So we do the math here. We have z sub 1 is equal to negative 10 all over 5. This is all equal to negative 2. Here we have 5 all over 5. So we have here z sub 2 is equal to 1. Okay, now let me just close it in a box so that it can be guided. So that's basically the z-scores that correspond to 40 kilograms and 55 kilograms respectively. Now the second step here is we will illustrate the normal curve. So second step. Okay, then just insert an image of a normal curve. So we have it's this one. Just insert, and we have to determine the areas that we're trying to look for here. That's what we need to do in the second step. determine the areas for our z-score, which is below the mean, -2, and also the z-score corresponds to our 55 kilogram, which is above the mean, and is equal to 1. So we're going to look at the z table. So let me just again insert the image again. So in the z table, what corresponds to our area z-score -2 is 0.4772, and the area that corresponds to 1 is 0.3413. So let's just try to indicate the areas that we have here. So we have here -2. It's -2 and +1. Okay, and this is equal to our 40 kilograms. Okay, and this is equal to our 55 kilograms. Now this area, let me just change this into green. This area is equal to 0.3413. So can you just check your z table? And this whole area is also equal to 0.4772. So those are the areas that we are that we will use for us to be able to determine how many children weigh between 40 kilograms and 55 kilograms. So now let's proceed to the third step. The third step here is we have to add both areas, because that's the so we have here 0.4772 plus 0.3413. So let me just write the third step. Add the areas, okay, from step 2. So the answer here is going to be 0.8185. And our fourth and final step is fourth step is to multiply the area to the total number of children whose weights were taken, first to determine how many children would weigh between 40 kilograms and 55 kilograms. So we have to multiply the area. Just write it down. So multiply the area with the total number of children. So the area that we have here the area is 0.8185. We multiply it with the total number of children, which is 1,000. Okay, multiplying it with 1,000, we have 818.5, or approximately, if we round it off to the nearest whole number, we have approximately 819 children. Okay, which is it's going to be the number of children that weigh between 40 kilogram and 55 kilograms. So let me just write it in complete sentence, the final answer. So there are approximately There are approximately 819 children weigh between 40 kilogram and 55 kilograms. Okay, and this is now our final answer. It's now our final answer. Thank you.